Hello friends of .NET, I'm Imo Landworth and you can find me on Twitter at TerraJobs. So in this episode, which is I believe episode number 14, we are going to add return statements to our functions. So in the last episode, I think not the last one, but the one before, we added functions, but we did not add the ability to return from functions. So in this episode, I'm going to add the ability to return from functions, which also requires us to build a control flow graph of the function so we can actually validate that all control flows through the function actually end up in a return statement. And that's actually not as simple as you might think. You think there might be some naive ways of doing that, like for example, checking that the last statement is a return statement, but that generally doesn't work when you consider that you have loops that you can fall through. You have loops like while true where the end is never reachable, so you don't want to get warnings for those kind of things. So there's a whole bunch of like interesting stuff going on. Also, in order to look at the control flow graph, you're using a tool called Dot or GraphViz, which is kind of the industry standard for rendering graphs. That compiler people and other people that have to deal with graphs often use as a way to debug their stuff. All right, then I think let's just jump right in. So before we go into the PRs, I would like to show something that I did yesterday. So you may have seen the Roseland source browser, where you can basically search for things in Roseland. And what's cool with this kind of thing is that you can click on symbols and you can actually jump to usages of it. So it's a symbolic browser and not just a dumb web search. So it's very easy for you, for example, to jump to definition of types. And if they're in multiple files, it shows you all the file stuff is in. So it's kind of useful. I did the exact same thing for our thing. So I bought the domain minsk-compiler.net. And if you go here, we actually have our stuff rendered in the browser as well. And so now when we actually go here to the parser, we see our parser. We can jump to source text, and all the other navigation, as you would expect, will work just fine. This is in particular useful if you want to understand, for example, syntax nodes, because you can just go to the base type, click on it, and then see here are all the types that are deriving from syntax node, and so on and so forth. So that's actually the way I pretty much learned Roseland and explore it on a daily basis. And in case you didn't know, we have the exact same thing for .NET Core as well. So if you want to just find, let's say, your friend list of T, for example, we have this as well going. So if you never use those websites, give it a shot. It's actually really nice to understand what's going on in .NET. And it's kind of nice that we have it for our project as well. And the way I set it up is that every single time I merge master, this thing is being rebuilt. It takes a few minutes, of course, because it's all static HTML files that are generated, but it's super useful. Quick shout out to the guy who actually did it. If you never heard of him, you should. If only I could spell his name. Kirill Osenkov, he's a developer on our team, basically. He works on the Xamarin tools. He did a bunch of cool stuff, like the MS Build Structured Log Viewer is another cool project that he did. And he built a reference browser, source browser, which, by the way, if you care about it, you can also find on GitHub. We have a fork here that we use for source.net. But the official source is here, which is basically the thing that I used yesterday to set it up. All right. Let me actually check whether. Yep, I seem to be live. It is always good. Let me check comments. My comments are working. I don't see any comments yet, but maybe nobody asked the question yet. All right, so let's go to PRs. Oh no, somebody says no stream on YouTube. Really? It's YouTube again, acting up? Let's see what's happening on YouTube. Oh, it says I'm live on YouTube. And yep, I can actually see myself saying I'm live on YouTube. So clearly that works. All right, so let's jump to the pull requests. So, why do I have it open twice now? Oh, because I'm an idiot, that's why. So before we go into the details, I would like to spend a few minutes on the to say something about the PRs. So I'm super psyched about the fact that I get a bunch of very interesting PRs from you folks. There's one for edit, try, catch statements, one for local functions, and one for the optimizer. So it's not that I don't like the PRs. My challenge is, because I've preparing these episodes, I have to think about how I incorporate large changes like that, because they change the structure of our language in quite significant ways sometimes. So I've not forgotten about these PRs, and I will definitely attend them. However, I want to really go through the episode today, because today is one with some non-trivial amount of work, and I want to make sure that this is taken care of before we go into the weeds and add some other cool stuff on top. So don't despair. I find what you did really cool, but I just really have to drive this point home today, and then I will take care of those. So now let's look at the more trivial ones. I don't want to mean that you didn't do any good work. It's just that it's very easy to review those. So here seems to be a bug. So we have effectively the following situation here. We have a while statement, and it looks like that we actually do this incorrectly. So basically, so the loop starts at 0, and while I is less than 5, we increment I, and if I reaches 5, we say continue, which basically should just jump straight here and then terminate. And apparently we don't do that. Let me actually check this out. Let's run this guy. Let's say show program. Okay, fine. Be like that. Okay, we print 6. So we say I is 0, we say go to label 1, which would be here, and we say go to continue 1 if I is less than 5. Okay, I plus I is I plus 1. Oh, that's right. So the problem is that our continue, so basically the way we emit the continue label for the while loop is that we basically logically put it here. That is not correct. When you say continue in a while loop, logically you have to jump to the check. In other words, the continue label shouldn't be at the beginning of the loop, it should be at the bottom right before the check. All right, that's good. So we changed, apparently when I renamed the project last time, I did not fix the launch file. Well, it turns out I never used the launch file. I just used the command line all the time. I'm a bad boy. Looks like here did the test. Bind while statement, we say bind loop body. Added a body label. That's interesting. Why would we add a body label? Seems to me the fix would just be to say okay, body label. Okay, so that's interesting. So the body is gone. Blah blah blah. Body. Okay, body and body label go to the bound loop base. That's fine, I guess. Okay, so there's a whole bunch of changes here. All right, so now we say we have bound label statement. So this is bound while statement, okay? We have a bound label statement. Okay, that seems to be also a bug that he fixed. Yeah, I'm not entirely sure why we needed the body label. How does he use the body label? Body label. Okay. Sure. Okay, they're in there. All right, I can see that. Okay, body label statement is this one. I see. So that's basically yes. So in general, I like the fix. I just don't like the fact that we now have this body label everywhere because we really don't need it. Like the only reason why we have it right now is basically in order to basically the only place where we use the label is in here, and we can just generate one similar to how we generated the check label before. The only reason why we expose the body and the continue and the break label in the bound node is so that when we are binding a break or continue statement, we basically know the label up front, right? But any other label that we may need during lowering, we just generate on the fly. We don't have to put them in the bound node. That's just noise in the bound node for basically no gains. Let me just quickly state this somewhere here. I don't think we should add the body label to the bound nodes. The reason that we have break label and continue label is so that we can access them during binding. We generally don't need to expose constructs. The body label should just be generated during lowering, like it already happens with what's it called, check label. With labels like check label. Boom, 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 boom. All right. And that's pretty much all my feedback, I think. All right. All right, so Jeff is asking what camera is it that I'm using. I'm using a Canon 5D DSLR. It's a really expensive webcam, but it really does a good job. In order to peer it with my camera, I just use a USB cable, and yeah, I think it's an app called SparkleCam. All right, so we have that now. Okay, this I think is an easy one. Sure, whatever. Well, I don't use nCrunch. That seems an easy one. Yeah. So this is an interesting one. So I reviewed this already. So basically the idea here is we have this writer that we added last episode where we basically, when we show our program, we actually print it in a nice fashion like we do here with, syntax highlighting and stuff like that. And the way I've done it is I just added some syntax highlighting stuff. And what he's doing, instead of having like hardwired literals everywhere, he's just using the syntax kind API to basically retrieve the actual string value. I actually kind of like it. I thought I wouldn't because I'm usually not a fan of over-engineering, but it actually reads really nicely and also fixes some other things like, oh, we have this space in here which is a little bit lazy, and he just added a proper space. So if you wanted to highlight, let's say, a white space differently from keywords, we could do that. And like, yeah, stuff like this, right? Now we do a space, a punctuation, and then a space. It is much cleaner. So in that sense, I dig it. Yeah, so this is an interesting one. So if you follow Jonathan Blow, who does a compiler as well, but his compiler is more geared towards a real industry strength compiler. He live streams on Twitch and YouTube as well, and like he has this rant ongoing many times that diagnostics of many compilers just suck. Where you get an error message, but the error message you're getting is not very well written. The location where the error was reported is usually, or not usually, is sometimes not nowhere near the actual root cause. I remember this a few years ago when I did some C++ after a really long break, and I just wrote a main program, and I got a squiggly on the int keyword before main as an invalid token, and I'm like, how the heck is that possible? Last time I checked, main methods were int main, open paren, close paren, open brace, close brace. But turns out the error wasn't there. The error was in my header file where I did not put a semicolon at the end of some class declaration. But of course in C++, because pound includes are just concatenated, the error message was reported elsewhere, right? And that's generally a really bad thing. So one of the biggest challenges in compiler writing is sometimes just getting the diagnostics right, meaning putting them in the right spot and squiggling the right things. And so what he's doing here, as far as I understand it, is so first of all, it seems like we are missing some test cases. So I'm always happy when people do that. But basically, here's what we do in the binder. We say when you invoke a function and the arguments you pass is not the same number of arguments that the function expects, we just say wrong number of arguments, and we squiggle effectively the entire function call. Which is not unreasonable, but at the same time is also not entirely helpful. So what he is doing here, he's basically searching for the first syntax node or the first argument effectively that is too much. So if you look at the test case here, he's basically calling print with 3 arguments, and he expects a squiggle for the comma up until including the last part. So all of this stuff is squiggled because that is too much for the method, right? Or function. And that's actually really nice. I was actually quite amazed by this because I didn't even think about it. And this is actually a really cool thing. I like it. And then yeah, you fix this bug here. So yeah, I noticed that already. So when we bind, generally when we bind stuff, we try to really hard to avoid cascading errors. So if parts of our tree cannot be bound, let's say we have 1 plus some string value, well then we cannot bind the 1 plus, and so we just basically bind this as an error, meaning we'd say the type of this expression is error. So when you have now the next operator on top of that that says, well, if any of my arguments are error, then I just don't bother binding. Otherwise, you get error messages like cannot find type, cannot find operator for int and error, right? Which is not super useful. And so when we bind the arguments to the methods, when we bind the argument to the function parameters, we didn't check for the error stuff. So if an argument would have the wrong type, we would say cannot convert error to whatever the function is taking. And now he's basically just saying if it's already the error type, don't report it. But remember the fact that we had errors. If we did, just return an error expression. So this is awesome. This is really good. Exactly. Better diagnostics, better dev life. Totally true. How many hours have we collectively wasted staring at compiler error messages? That is quite a bit. All right, I reviewed this one. And the other ones I promise I will look at. I have not forgotten about you. All right, so now it is time. Let's pull. Let's build. Test our passing, always good. Episode 14, did I say, right? Yes, let's launch this guy. So here's a quick tip for you. You might notice that my status bar is not shouting blue anymore. Instead, it has a more reduced color. And I do this by having this custom theme, if I find it here, color theme, called Dark Plus. Now this is not confusing at all because there's an actual theme called Dark Plus with a plus character, which is the built-in one. This is the one that the community member built. You probably should have called it Dark Plus Plus or something. But yeah, it's basically, this is the normal theme. Whoa, look at the status bar. I'm blind. Oh, look at this beautiful status bar. So, I don't know. It's the small things in life that keep me happy. Alrighty, so now let's talk about function return. So the first thing we have to do is, of course, lex this guy. So lex the return keyword, which, no, it's not here. Keep making that mistake. It's a keyword, so we don't have to do much. We only have to say it's a keyword. So I would return go, probably between L and T. So we call this the return keyword. And then, of course, you say if the string is returned, then it is a return keyword. Let's put this guy. Can I do this? Select all of them and then F9? No, F9 is a breakpoint. They must have a sword somewhere. Ah. Sublime had a sword. Pretty sure this one has a sword as well. I'm just too lazy to find it. All right, so now we lex the return keyword. That's great. Let's actually go to some statement. That's funny. Oh yeah, no, that's actually I was confused for a second because I'm like, didn't I introduce a loop statement? But I did, but only in the bound tree, not in the syntax tree. All right, so we have a return statement syntax. Yep. Let's do a constructor. And this constructor would take the return keyword, right? So it would be a syntax token, return keyword, and we have, of course, an expression syntax expression, which would be optional. Let me say this is syntax kind return statement, which would go here. All right, so now we have a return statement. I love it. Now we have to parse it, which of course parse statement. Here we go. We just have to add this case here. So if you're standing on a return keyword, then we just say parse return statement. This is exactly why I don't know why people freak out over parsers. Like, I mean, I can literally add another statement in like 10 seconds. Yes, there are some things here that are not super easy in the parser, but in general, it is not terribly complicated. All the problems that we usually have are nowhere near the parser. They are usually, oh my god, we completely checked, messed up type checking or something. All right, return keyword. And then we say this is a return statement. And of course we need an expression. Oh yeah, I remember now. So here's an interesting tidbit for you. Parse expression. So our intention is similar to C#, right? Where we can say return 42 and a type 12, funny enough. But we can also say return without anything, right? In normal functions that return void, you still may need a way to just quickly terminate the function. So I just said parsers are easy, but this is actually an interesting problem. So how do I know that I should parse an expression? In C#, that's pretty straightforward, right? Because in C# you either have return 42 semicolon, or you have return semicolon, right? But you definitely have a semicolon if the statement is complete. So basically, I would normally say, if next token is semicolon, well then don't eat an expression. If the next token is not a semicolon, well, then don't, right? In our language, there are no semicolons. So how do I know that I'm not supposed to consume, whatever starts in the next statement, expression, whatever, right? And the answer is we don't really. So this is a language design problem, not so much a parser problem. The way we can solve this is by saying, well, white space is usually not significant, but in this case it is. So if the next token is on the same line, we assume it's part of the expression of the return. If it's not, then, well, it's not. So this is not necessarily great, but it kind of works. So we can say keyword line would be keyword span start. So we would say, what is that, text, get line index for this position. Then we can say current line. That would be the current keyword or the current token. And then we can say same line if it's the same line. Well, didn't I recently fix a bug in this? think on one of my dry runs I figured out that this condition is not sufficient. Well, if same line, parse expression, otherwise null. If anybody can see a problem with that, let me know. I'm pretty sure I'm missing something obvious here. Anyway, we will find out. All right, so now we have this guy. Now we have it parsed. Not sure why it shows up as this, but hey. Now we need to add it to our bound tree. So same concept here. We go to some random statement. And then we call this bound return statement. And of course, this guy will get, what is this, bound expression. Oh yes, of course it just occurred to me. Parse return. So of course the only other condition is EOF current kind is syntax kind end of file token. So if it's not end of file, then do that. All right. Crisis avoided. I remembered. No, not a null check. Bound expression, and then of course we need to implement this guy here. So we say this is bound node kind return statement. And then we can move this guy to a secondary file. And now I can just do this, and this guy should probably go here. All right, so now we have that represented in the binder. Now we just have to bind it. So bind statement. Here we go. This would be return statement. Let's go to the continue. So we've expression is bind expression, syntax expression, return new bound return statement for the expression. So a couple of things. So first of all, before we go here, let me actually fix the rewriter because that will otherwise break me later. So this would be a return statement. Basically same concept. First we write the yeah, well, let's call this expression, and let's call this expression. All right, so important part, if this guy is null, then it's null, otherwise we rewrite it. Okay, so same here, if syntax expression is null, then it is null, otherwise you bind it. So Of course, this is not sufficient. So a few things we need to check. Does the function have a return type? Does the return type match, right? So I think we need to do a few things, I guess. So do we have the function right now? We should be having the function as a field item. Okay, we know what the current function is. So if function type is type symbol void, and well, let's do this. If expression is not null, then we say diagnostic report invalid return expression for syntax expression span. Right? So if the function is void and we try to return something, that's an error. Else, so the function isn't void. Now the question is, if yeah, we just have to say expression is bind conversion for syntax expression span. It's our diagnostic span. The expression we want to convert is this one, and the target type is, of course, function type, and we don't allow explicit because, of course, it needs to be implicitly convertible. This guy will report an error if that is not convertible. So of course, now we have to say if expression is null, else we do this. In this case, we would say missing return, right? It would say report missing return expression for return keyword span. That looks right. Let me just take a quick look at my notes because I think there's a case I'm missing right now. Oh yeah, the other thing that is missing is what if we're not inside of a function? So if function is null, then we would say diagnostics report invalid return for syntax what did I say? Span. All right, so this looks about right. So we're basically saying if we don't have a function, then we say you can't use return. If we do have a function, and the function is void, then we check, well, do we have an expression? If so, then you can't have that. If we don't have a return type of void, well, if you don't have an expression, then that's a missing expression. Otherwise, you bind the conversion. Looks decent enough. So let's add some error messages. return keyword can only be used inside of functions. All right. Since the function does not return a value, the return keyword cannot be followed by an expression. Since the function yeah, screw it. An expression of type expected. All right, that seems reasonable. So now we have to say function.name, and here we have to say function.type. So someone is asking, I think Jimmy Scott, you may have mentioned this before, but wouldn't it be better to move these statements into the syntax class itself? Well, this is kind of a philosophical viewpoint, I think. So the object-oriented way would be you have all these functions here, like bind, return statement, all of them. They would effectively live on the syntax classes, and then you would do them there. You know, I've written stuff like this a few times, and I've tried various approaches. I've also read a bunch of code bases that do this kind of stuff, and I feel it's very unnatural. So if you look at how functional programming works, or how you know, traditional C-style development works, you basically have functions on the one hand side, and you have data structures on the other side, and you have the data structures just operate on the functions just operate on the data structures. That's basically what we have here. It's like our trees, our bound tree, our syntax tree is effectively, there's no code inside of them, right? I mean, there is code inside of them, like toString or some other stuff, but they're basically pure data holders, right? Versus the binder and the parser and, you know, other stuff like the rewriters, they are the ones operating on the data structures. That in itself leads, in my opinion, to better resulting code, because I like actually that the binder is all centralized in one spot. Because it's so much more natural to say, here's the thing that walks the tree. So you have all the stuff that deals with particulars combined in one type. So for example, if you need helper functions for common operations, they belong here. Instead, if you split them in like hundreds of types, it's very hard to reason about what your system as a whole is doing. The other thing is that very often when you do things like this, the structure is not the same, if that makes sense. So for example, the binder very often, you know, we don't have a one-to-one correspondence between syntax nodes and bound nodes for good reason, right? Because some of the stuff is like, well, you know, a break or a continuous, there's no reason to have a bound statement for them, because a bound label statement has exactly the same amount of information. And so if you split them into two separate concepts, like the data structure and the walker, or the data structure and the producer, if you will, or consumer in general, I personally like the readability more of it, but I guess that's more like a personal style. I hope that answers that. Yeah, in general, like, I mean, if you look at all my code here, like I try to like centralize cross-cutting concerns. For example, error messages, I have just these methods here, so I don't have magic strings all over the place. I just have them in one place. So for example, if I now want to do a pass over my error messages and see like, is the phrasing consistent? Well, you have it all on one screen. Like, it's super easy, right? If they all split, spread throughout the entirety of the compiler code base, then, well, good luck, man. Good luck, right? So yes, you can grab them and all of that, but like, I don't know. I just like this style a lot more. All right, so then we have that. Now let's see what ends up happening if we feel like I have forgot something here. Rewriter plus now, we have these guys. Oh yeah, there's this thing called evaluator. Where we have to handle that statement now. That would be in here. Return statement, we would say var. So yeah, return value is s rs. And if this is null, then it's null. Otherwise, it's evaluate expression for rs expression. And we just say return value. Right? Probably have to say this for consistency reasons. Although it is also something that we need to remove eventually. So now let's see. So let's say var x is 10, var y is 20. Well, 20. And then let's say function sum int is return x plus y. Yeah, I remember that one. This one we can now delete. Question is which part is blowing up? The binder right here. Yes. Let's try this again. Wow. Let's go a step further. Let's take arguments. X int, y int. Some. Nice. All right. So we move this, added the return statement binding. Okay, let's actually maybe play with this a little bit more before we get crazy, before we get carried away. So if I have a function sum that returns nothing and I try to return something, that should work. If I do this, since the function sum does not return a value, the return keyword cannot be followed by an expression. All right, that makes sense. Let's say this returns a string, then cannot convert type into string. An explicit conversion exists. Are you missing a cast? That's actually quite nice, I have to say. All right, now let's say this returns an int and we are trying to do 42. I think same thing. This works. But if I try this, then same error message. All right. So, and yes, if I do this, then I get an error message and says I can only use this guy inside of a function. All right. So that seems to have worked. All right. Return statement. Yup. Yep. Yep. Move this guy. And then we added these guys. Yep. All right, return statement. Yep. Remove the blank line, sure. Return keyword. Parse it. Like said. All right, sweet. And return statements. And then for good measure, did I close my browser window again? I did. And now, of course, it pops up on the wrong screen because why the heck not? Episode 14, return statements and control flow. All right, so here is stuff that is happening now. Oh yeah, of course, I forgot. All right, that makes more sense. Yes, control flow. So what is the problem right now? Well, the problem right now is I can author functions that don't actually return, right? So what happens when I do that? Actually, I have no idea. So let's do this and say 12 times sum. Yeah, we return null, and then of course that gets a null reference expression when we try to, a null reference exception when we try to take the right-hand side that returned null and cast it to an int. So yeah, that's bad. Well, how do we know that we're not returning anything? Because that's actually not that straightforward. So one thing we could do is basically just check the body for the presence of a return statement. But that generally speaking doesn't work because, well, it depends on how you author the function, right? You can have stuff like this, right? You can say function sum, let's say a is int. Yeah, let's do this, sum and int. And then we could say, var result equals 0. And then we can say while true. And then we can say, let's say var I equals n. And then we can say if I is the same as n. Then we return result. Otherwise, we can say result equals result plus I. And then we can say I equals I minus 1. Right? That's a legal function, right? Because there's no way this loop can ever terminate. And so the only way we can quit this thing is from within here. So in the if analysis of this thing would say, well, you're supposed to have a return statement here, right? Which is actually not reachable. So we need to do a little bit more thinking in order to figure out how we can do this. And there's a generalized way this is being done in compilers, and that's called control flow analysis. I'm actually somewhat confused where my screen is. Do I have to go on the other side? No. Where is my screen? Oh, I see. Because I'm like, my cursor, I can't get over. It's hitting a wall, but the monitor is down here, that's why. Well, let me scroll a little bit here in my notes. So what we'll do is we will go into our binder here. We add a completely new type and call this internal sealed class control flow graph. Move the type. So what does the control flow graph look like? Well, there's a few things we need. There is basically the control flow graph consists of effectively nodes and edges, right? That's not surprising. That's any graph ever done, but these are specific ones. So we have this thing called basic block, and we have another one called basic block edge. So logically, a basic block is a piece of code that is not so it's basically a list of instructions. So they're all flattened. So the control flow graph, we will compute this over the lowered version of our functions, meaning we don't have higher concept anymore. It's just a flat stream of instructions with labels and gotos. So basic block is basically a section of instructions that where only the first one can be a target of a goto. So everybody in that block effectively cannot target it individually. And then there's no control flow out of that block except for the last statement. So in other words, it's effectively the atomic parts of your program that will run consecutively, right? And then effectively between your basic blocks, you have branches, right? So you have an if statement that says if this condition holds, then you basically just keep executing. And then when the branch hits, then you just transfer control to another block, right? So effectively, a basic block has a block that it comes from, a block it goes to, and a condition that it has. So logically, we would say this guy has, a from, a basic block to, and then an optional expression, let's say condition, right? Condition, right? Blah, blah, blah. All right. And then a basic block is effectively a list of bound statement. Statement is new. Yeah, by all means. And let's make it a halfway sane by actually using properties. I just use list here because screw it, life's too short. We will construct this graph in an incremental fashion. So constructing a graph in an immutable way is actually quite hard. We call this incoming. No, actually, that's not the right one. We need edges here. Dum, dum, dum. We call this incoming, and this is outgoing. So each node effectively knows what its incoming edges are and what its outgoing edges are, which is quite neat to have as a representation. So then we say, well, this guy gets constructed with a few things. We basically have a basic block start, we have a basic block end, and then we have the actual blocks, list blocks, and then we have a list of edges. I click around a lot, but that does not actually help my case. All right, so that's our graph. Congratulations, you were able to assign a few variables into a property. This looks good. Does this representation make sense to anybody? All right, so let's do a public void write to text writer, which we will need later in order to emit our stuff. So let's do this first, because we will, once we edit this guy, we really want to be able to look at it as human beings. So there's this thing that I already have. So where's this guy? Graph dot. So if you never used this thing, it's called dot files or graphviz. And this is effectively the representation of the graph. So there's actually an extension for VS Code you can install, which to my knowledge is cross-platform available as well. So you don't have to be on Windows. And so what this thing basically does, it just renders this thing as a graph, right? And so basically you declare your nodes, and then you declare your edges. And then each one of them has attributes, so you can specify some label, you can specify the shape. So if I wanted to, I could say this is a circle, right? But it doesn't really matter, right? And then this one here is effectively line breaks, and the \L just means left aligned. So if I just do these guys, they would be centered, but we don't want centered, because if things get really long, that looks weird. And given that we write statements, you want them left aligned. So we do it like this. And then stuff kind of makes sense, right? So basically what we have to do here is basically just output this guy. The way we would do this is we would say, let's start with writer write line. Yeah, we probably need the O namespace, and then we start by saying this is a graph. And then we would say for each var node in, yeah, that's great. Let's call this maybe blocks. For each block in blocks, block IDs is new dictionary string. No, what is it? Basic block string. So first we generate basically our IDs, so we can refer to these guys in a convenient way, and then we just say the ID is just uninspired NI, right? And then we can just say block IDs, add blocks of I with the ID. All right, and now we can just say for each var block in blocks, same concept. We just say this is block, no, block IDs for block, and then we just say 1, 2, 3, 4, and then we just say this is where the ID goes. And then what is the syntax here? We have a label. Okay, what the label be? This is the label, and then the shape is box, I think, right? Apparently there's no comma, because screw readability, right? Who needs to read stuff? This is for machines. All right, so this is this one, and then let's do the edges. Same concept here. Edges, we call this edge, and we call this from ID is edge from to, and then we can just say this is to ID from ID to ID, and then of course we don't have this one, we just have labels. All right. And then the labels in our case would be somewhat straightforward. So let's just say we just call toString on this guy. So we say toString, and then we just replace any new lines, environment, new line with the left alignment character. And then here we would say, well, what does our bound node toString do? Yeah, we just do that. Okay, that's great. So then we just say, if the edge condition is null, then it's string empty. Otherwise, it is edge condition toString. Nice, nice, nice. So I think this is basically what we want. Now, before we forget, let me go to the compilation and make sure we actually emit this guy. So in the iterator where we get the program, this is where we would do this. So CFG statements, we would say program statements any. So if we have any sort of global statements, then those are the ones we analyze. CFG statement. We do this one. Otherwise, we say if program functions any, then we say take the last one and take the body. Otherwise, okay, how about this? We say if we don't have any and we have this one, does this sound right? Something like this. Basically, the idea is if we have global statements, we use them. Otherwise, we use the last function if it's available. And then this one we just do to make sure that we always have a return value. All right, so now we can say var CFG would be control flow graph create, which doesn't exist yet, which we have to do for this statement. And then we would say, what's the path? We say var app directory is, well, let's start with app path. That is environment, get command line args. The first one is the path to the exe, and then we say app directory is path.get directory name for app path, and then we can say var cfg path is path.combine for app directory and cfg dot. Right, and then we can say using var stream writer is new stream writer for this path, and then we can say cfg write to cfg path, no, stream writer. All right, let's create this guy. So this is a control flow graph. All right, now we will just say return new control flow graph for, yeah, some stuff. Let's get this to the point where it compiles. All right, so the only other thing we need to do is use a block. So we have always these special blocks. So basically the idea is that an empty function will have a start block and an end block, and they're just directly connected. And then the statements just go in between. So this way you always have a single entry point, you have a single exit through your function. So in order to model this, we will have a constructor here that says blocks with statements are constructed like this. And then the special ones are constructed with this. So we say bool is start. We say is start. And then we say is end is not a start, right? And then we just say like that. All right, so now let's start with creating basic blocks. So we say private, actually let me put them up here with the other ones. Public sealed class basic block builder. We say we start with bound statement. I guess it's bound block statement. Block. More like this. So what does that mean? So we would say we pass in the basic, the bound block statement here. And then we basically produce basic blocks out of them. Well, how would that look like? Well, clearly we have to say private list basic blocks. Blocks is new, this guy. In fact, let's do this to make sure we say just return blocks to array. So what does that mean? So we would basically say for each var block in blocks, sorry, switch statement kind. So basically, let's walk the statements. So what statement kinds can we have? So here's all the statements that can occur in principle. Case, bound node kind. Right, so we know for a fact throw new in exception unexpected statement kind. All right, so we know for a fact we cannot have blocks anymore because we flattened this whole thing. So we can have variable declarations. We can no longer have if, while, do, or for because we already lowered them into labels and gotos and conditional gotos. We can still have return, and we can still have expression statements. All right, so basically, in this case, you would say private basic block current. No, not really. We would say bound statements. So we would say, okay, this guy gets added. Right. A label statement. Clearly we become a target, which means you would say start new block. Sorry, start block. And then we add the statement. A go-to statement, we first add the statement, then we start a new block. That is also true for the conditional go-to. That is also true for the return statement. Which now means we can combine these here. So label statement starts a block. These guys end the block. And these guys are just adding to the current block. Right. Then we would say finish block. Let's say end block. So we now need a few functions here, generate block and end block. So that means we end the block and then we say, of course, so end block if statements any. So if we have any statements, then we say var block is new block, basic block. And then we say block statements add range, the current statements. Then we say statements clear. And of course we say blocks add block. So our start block doesn't have to do anything effectively. So that now means if we don't have any statements, we call end block, which now means since we don't have any statements, we do nothing. So basically our blocks is empty. If we have one statement, then that means, let's say, worst case, we just have statements. M block will produce a block, so you get a single one. Otherwise, you get multiple ones. So that sounds about right. All right, so let's try this. So let's say var start is new basic block is start true. We say end is false. And then we can say var basic blocks. Actually, let's do this, but let's call it toList here. So we produce a copy, but that's fine. All right. Var basic block builder is new basic block builder. Var blocks is this guy built for the CFG statement. Let's call this statement. Let's call this, yeah, let's call this statement let's call this body, because that's what it really will be. And then we can say blocks insert start, blocks add end, and then we can say new, what is it, control flow graph for start, end, blocks, and new list of basic block edge. So we have no edges for the time being. All right, let's run this and see what ends up happening. So that means we should have written a file here. That's great. Okay, there's a syntax error. Okay, that's that's not great. What's the syntax? Oh, because we just emit. Okay, let's do this for now. But basically we have 3 nodes. All right. So let's see what we can do to fix this. So basically our basic block here, we would have to override toString, override public, override toString, and we would say var string builder, new string builder. So first you would say if is start, we say return start. Is that the magic? Yeah. Is end. Otherwise, now we say for each var statement in statements, we would say, yeah, that's actually not helpful. Using var string writer equals new string writer. We would say statement write to the string writer. And I believe those guys will, generally speaking, have write lines in them. Yes. All right. So that means we can do that. And then all you have to do is say string writer to string. All right. Let's try this again. That looks almost right, but we need to emit the quotes. So this would be I believe, yeah. Yeah. So basically we need a leading quote and we need a trailing quote. And in between, let's do this, put this guy somewhere here. Yeah. And then all we have to do is say quote this guy. And same thing here, we can say quote this guy. All right, one more time. All right, so now what do we have here? Congratulations, we have a very lame version of a control flow graph. But at least we can see what's happening now. Yeah, God knows why I closed the file. Now let's think about how these guys are being connected. So basically we need another class here that actually does the construction for us. Public sealed class graph builder. And we would say public control flow graph build given this guy. No, not given that guy. Given a list of basic block. Right? For now, I can just do that. Put the stuff in here. Don't need that. Let's call this blocks. There we go. And then all we have to do is var graph builder is new graph builder, return graph builder build for the blocks. This is all that code now. All right. Now we have a thing that can actually store some state, and now we can do something useful, hopefully. So now we need to think about how we connect this guy. So we certainly need some edges, right? Private list of basic block edge. Actually, we want to call them branch because that's really what they are. They're control flow branches, right? So instead of calling them this, we should just call them branches. Branches. All right. And then probably, oops. All right. Consistency restored. Not that it matters, but if condition is null, return string empty, otherwise return condition to string, right? That makes this a little bit easier on the eyes. All right, so now let's talk about the builder. All right, so now we have our start, our end. So how do we connect stuff? Well, we said there are branches, new list of branches. So clearly, we should do that. So let's say if we don't have any blocks, then we should probably connect start and end. Otherwise, we should connect start with blocks first. So let's generate this guy. So what would that guy do? Well, it would do a few things. It would basically say we need a branch, new basic block branch from to has no condition, bound condition which we say is optional. Yep. And this is really an expression. Let me say condition here, obviously, and then we just have to say from outgoing add branch to incoming add branch, and then branches add branch. That seems right. So let's just see what happens when I run this. Not that I don't trust myself, but I don't trust myself. The given key start was not present in the dictionary. What? 186. Ah, yeah. See, this is why I said I don't trust myself. We have to say blocks insert 0 start, and we have to say blocks add end before we return. So this should give us congratulations. Start is now connected to this one, and if it's empty, which I think we can go like this, right? Or we just have start directly going to end. All right, so this is not bad. This is not bad. Now let's do something maybe some more interesting. Var result equals 0, for I equals 1 to 10, result equals result plus I, result. Right? Now this looks like this. All right, now we have a few basic blocks here. So here's our first basic block. We just initialize a bunch of stuff. Then we say go to label 2. This is this guy. And then we say go to label 1 if upper bound, so we go here. Yep, so this looks right. So we now have a bunch of basic blocks floating in space, but not actually being connected to anything. So now let's actually do the connection stuff. So how do we connect them? Well, a few things. First of all, we probably need to remember, so in order for us to make sense here, we basically have to walk the statements. But we need to know a statement's block. So first thing we would need to do is we have to say private dictionary from bound statement basic block. And we call this block from statement. All right. And then we have something similar, but in this case, we go from a label to a statement, from label to a block, and we call this block from label. All right, so for each var block in blocks, for each var statement in block statements, and then we just say block from statement add block comma no the other way around, statement comma block, right? And then we can say if statement is bound label statement, then we can say block from label add label statement label to block, right? That seems moderately right. After we index the whole thing, now it's pretty straightforward for us to just walk over the blocks again. But in this case, I think we want a for loop. And then we can say var next. So if I is blocks count -1, then the next block is the magic end block. Otherwise, it is blocks I plus 1. Yeah, if only I could write code. And then we only have to do walk statement for the block, for next, right? Yeah, and we probably want to know whether it's the last one in this set as well. Yeah, so okay, we also need to know whether it's the last statement. Var is last statement in block. That would be if the statement is block statements last. By the way, you might think this is horribly inefficient, but it's actually not. Because this is a list. Yeah, this would basically just directly go to the last index, so it's fine. Not actually walking the whole thing every single time. All right, now we just have to do the switch statement, kind. So same thing, what can occur? We already have the list here. Here is what can occur. So let's get rid of these guys. I think the order was slightly different, but not that it matters a great deal. But let's just be consistent. And then just say, all right, walk statement next is last statement in block. All right. Now we only have to add a bunch of breaks. Now let's add some methods. All right, so cool stuff. And something tells me that this is all messed up. What's happening here? What is wrong? Empty switch block. Oh, I'm inside of a switch block. Yeah, that doesn't work. Here we go. Now things make a lot more sense all of a sudden. Let's do this again. Now also colorization is not way off. Isn't that nice? All right, so now let's do this. For an expression statement, actually, do I need all of this? Might have been a good idea to actually think about this before we generate a bunch of methods. Yeah, let's not. Let's not do those because that would be weird. So variable statements and expression statements, we can still deal the same way. And we would basically just say if is last statement in block, then we connect actually, let's do that too. Let's pass in current. We call this current, and we call this next. So then we just say connect current with next. Right? And we only do this for the last statement in the block because, well, if it's in the middle of a block, we don't care. Because of course it's logically connected, right? That's the property of a basic block to begin with. A return statement, we would say return statements are always connecting the current block with the end. And so right now the end is unfortunately not reachable. So let's do this. And then let's say, really? Really? Yeah, whatever, man. Whatever. I type it, it's fine, it's fine. All right, now we have this block. Now we can say we are connecting the current one to the end block. And then the conditional go-to statement is a bit more interesting, and the go-to statement is also more interesting. So in this case, we would have to say var go-to statement is bound go-to statement for statement. Now we would say var2 block is block from label for current. No, for go-to statement label. And then we would just say connect current with the to block. All right, now we say conditional go-to statement is, of course, bound conditional go-to statement for statement. Now it gets a bit more interesting. So, of course, we connect this the same way. Let's call this the then block. But the condition is our condition, right? And that would be this condition here, except that we have this whole thing like yeah, what's the condition? Yeah, so basically the condition is condition. So if this one is jump if true, let's make this shorter. Then it is CGS condition. Otherwise, you have to negate the condition, right? And then we can say else. Let's call this the then condition. And then we can say the else condition is effectively the same thing except it's reverted. So we can just cheat here. And boom, now we have it the other way around. Let's call this negated condition. Let's only do this once, maybe. And then, of course, we can say current to, we can just say var else block. That's just next, right? So we just fall through. And then we just say this is the then condition. And that is the else condition. In fact, let's make our life easier. Everything in one method, yeah. And we call this guy current. All right, now we need a negate method. So let's do this, negate. So how do we negate this? We're saying if condition is bound literal expression, literal, in that case we say var value is condition no, what am I doing here? What am I doing? Literal value cast to bool, and then we just say return new bound literal expression for this guy, right? We just negate this guy. And of course, this guy returns a bound expression again. If it is not a literal expression, then we would say var unary it doesn't matter. Var unary operator is bound unary operator bind for syntax kind. What's this thing called? Bang token and type symbol bool, right? Basically fabricate, and then we say return new unary expression, new bound unary expression for the unary operator and the operand would be our condition. Right? Something like that. So there's no way this was correct, but let's try this anyway. Yes. Actually, awesome that you add visualization of the control flow even at this stage. As a visual person, I appreciate this very much. I don't know how people debug otherwise. Like, I've had a coworker who would never do this, and it's impossible. And when you're standing in the debugger and you have like 12 objects in memory and they all point to each other, my brain does not work like this. I'd rather spend the 20 minutes or whatever it is to write the stuff in some form or fashion where we can actually look at it, so that when stuff like this happens, I mean, okay, in this case, you probably can't do much because we crashed, but most of the time it succeeds, but then you have like garbage and you have no idea what it even looks like. All right, so unexpected statement, label statement. How is that possible? What? Graph builder list, line 197. You're blowing up here? How is that possible? Oh yeah, I'm an idiot, that's why. For some reason I must have accidentally deleted the label statement. No idea how that happened. All right, now we have something. I'm shocked because that almost looks correct. Let's take a look. All right, so we enter the method. Here's the initialization for our local. Then we say, okay, go to label 2. This is our loop, right? So we say, if I is less than or equal to upper bound, that's when we go to this one here, result equals result plus I. Then we say, what is that? Okay, we just unconditionally go here. Then we say I is I plus 1, and then we go unconditionally right here. And then we go from here to here if I is, yeah, it's basically if this condition does not hold, then we just do result, and then that's when we go to end. This is nice. Question, what is the difference between switch case and if else? Is there any difference in compilation? I'm probably butchering your name. I think it's Saya. So it kind of depends on what, I assume you're asking about C#. Well, the nice thing is we don't have to guess. So let's just open our compiler really quick. This is probably under Minsk source. Am I or am I not? Debug netcore app. Let's go to MinScale. So what do I have in if else? Well, let's first go to build, maybe. This is in, where was I? Binding, control flow, where are you? Control flow graph. Block builder, control flow builder, right? Graph builder, build. So here you can see this is basically a decompiler. If you never used a decompiler, it's actually quite good because you get a sense for what the heck is going on. So we can actually move to this IL with C#, which is, I'm gonna zoom in here. Is there like a options, display, consolas? All right, brace yourselves. I'm just guessing right now. Yeah, that's not bad. So this is basically what it looks like in IL. So somewhere in here we have our switch. Let's just search for switch. So what you see here is switch statement for kind. And what you see here is there's a switch keyword in IL, and it basically gives a bunch of labels. So logically, what this switch statement compiles down to is a jump table. And so logically, when you think about these guys here, right, these labels here, they're all constants. Specifically, there are enums right now, and so enums are just ints. So logically, what the compiler could do is effectively have a table or an array where each int value effectively becomes a label, right? And that's kind of what the compiler does. And like if you look at here, it does some sort of subtraction. So basically what it does is like it sorts them basically by the int values. And then for the first one, it basically discounts subtracts basically the offset so that your array is 0 based effectively. And then it just basically has one label per int value. And if you have gaps in these guys, the compiler will try to, make some sort of, I don't know what the estimate is, but effectively it will try to split them up into two different jump tables if it's worth or something along those lines. An if statement is literally just, if you look at, well, an if statement somewhere here conveniently. Right here, if blocks any connect, right? This must be somewhere up here. Well, this is a bunch of locals. Yeah, if blocks any. Basically, we just load the first argument of the method, then we call this, method here, and then we say load a constant 0, and then compare them to equality. So basically, we just compare the result value of this with 0, and then we store it in the local, and then we say load the local. If the current local has the value false, then jump to this one. So it's basically exactly like we do it, right? So logically, you just say you evaluate a condition, and then you have effectively like a sort of an instruction that says, depending on whether the current value is true or false, you branch to one thing, right? And you could totally omit, you can omit any switch statement as an if statement, right? We say you compare this to this. If it's true, jump to this, otherwise jump to the next. And then you rinse and repeat. But that's not very efficient, right? That's why jump tables are usually super, super cheap to access. I hope this answers the question. All right, so this looks not bad. So now a few things. So now let's actually try something like, let's write this as a while loop. Let's say, what do we say? Var I equals 10. We say while true. We can say if I is 0, break. I is I minus 1. All right, so this is what this looks like. So we enter this guy, initialize a bunch of stuff, go to label 1, go to continue if true. Yeah, so one thing we probably want to do is, if the condition is always true, the condition is always false, don't connect them. Or, just connect them without a condition. So how will we do this? Well, if condition is bound literal expression, value would be bool l dot value. So if value, condition is null, else return. So in other words, we just omit the label because it's effectively an unconditional jump. And if it's false, we just don't connect it ever. So, okay, I'll have to copy this to the clipboard now. And we are almost there. Bum, 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 bum. Here we go. So we enter the block, we go to continue if true, which is now an unconditional case right here. Then we say go to label 2 unless I is 0, in which case this is the I0. We go to break, this is here, we go to end, otherwise we go this way, right? So now let's actually do something more interesting. Let's actually declare a function, sum, and int, returns an int, and then instead of saying break, we say return result, and then we say return -1. Unexpected node return statement. Oh, snap, we did not add our bound. Okay, that's actually a problem. Bound tree printer. No, bound node printer. That is unfortunate. What is this? Conditional go to the expression statement. All right, here's probably where this guy should go. We say this is a return statement. Jip, 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 jip. Add this guy. Right. Conditional here. All right. So what do? We would say return expression. Didn't we? Syntax kind. What is this? Return, not symbol kind. Syntax kind. Return keyword. All right. So now we say if this guy has an expression, right? Let's copy this guy. Lo and behold, what's happening? Yes. All right. So clearly, this statement here is unreachable, right? Because this loop never terminates. So the only way we will leave this loop is via this statement here. So we can see this in the control flow graph because break does not have any incoming edges, right? So this guy is effectively unreachable. So let's actually remove those guys, which we will do here. And we will do the following. So we will basically say for each var block in blocks, and then we say if block incoming So if the block doesn't have any incoming edges, then we say remove block. And then we call this guy scan again. I know, I'm a bad person, I'm using goto, but this makes it so much easier to read in my opinion. So effectively what we do is like the idea of this loop here is we always have to restart this loop every time we remove something because this collection will have changed. And so yeah, before we have to pass in the blocks, all right, because we have to remove it from this thing. So let's do this. So what does removing a block mean? Oopsie, what's happening here? All of it. Well, first let me arrange our helper methods here in somewhat of a more reasonable way. All right, so remove block. Well, if you remove a block, clearly we need to remove it from the collection. Blocks, remove block. But also we have to say block outgoing remove. No, block. Hold on. What do we have on the block? I'm confused. So if we remove a block, basically we have to go over all incoming ones and remove the outgoings, and then from all the outgoings we have to remove the incomings, if that makes sense. So we would say for each block, for each from in blocks block incoming. We would say from incoming from outgoing remove this guy, right? And then same thing here, we would go for the outgoing and we would say to incoming remove this guy, right? Seems moderately right. Which now should mean if we run this guy again, key not found. The given key break was not present in the dictionary. I guess that's bad. Oh yeah, it just crashed. Okay. What? I'm blanking right now. The given key break one. So what was break one? So clearly the problem is this one here, right? So we're running through this guy, so we're removing, so we haven't added our start and end nodes, which is deliberate because we never want to remove those guys. So for each block in blocks, if block does not have any incoming edges, remove the block, try again. All right, that's not bad. And then we basically say for each branch in block outgoing, branch to incoming, remove that branch. Yeah, why would that not work? So it looks like we removed something, but only partially. How is that possible? What is happening? So the incoming edges will have no, I'm not seeing it. I'm really not seeing it. So I guess maybe we just debug it. No, we don't want to attach. We want to launch it. Let's get this guy. I guess that must have been a PR that it didn't actually end up merging. All right, now tell me, what do we have? Okay, so that seems reasonable. All right, so now we have removed all the blocks. So we have said, okay, that is awesome. So nobody's going to label one. So why? So that seems reasonable. All right, and you have no outgoings. I have incomings, which is just one basic block. From return to end. That seems all very reasonable. I fail to see why this stuff would not work. Oh, because I'm an idiot. As usual, the problem is often much more mundane than you think. So, very simple problem. All correct, except for the part where we forgot to say branches, remove branch. Annoying. Yeah, that's not what we wanted. Oh, let's not clear this yet. Otherwise, bad things will happen. What just happened? That is very weird. No idea why that was. Anyway, so let's actually go back to the file list. Let's open this guy. Let's open this guy. Let's visualize it. And yep, so our break is now gone. So the return -1 does not occur anywhere in this control graph anymore because it's unreachable. So why are we doing all of this madness? Well, now we can finally write our function that we care about. Public static bool all paths return. For, let's say, a function symbol function, we can now say, maybe not, maybe we just say the bound block statement body, and we can just say var graph is create, and then we can say graph and incoming. So if graph and so incoming can never be empty, right? Because we always have the start one connected. So all we have to do is we have to say graph incoming, graph and incoming all so you have to say all of those guys have to be, let's do this, for each var block in graph and incoming, actually for each branch, you say then for each var block, actually for each statement in branch from statements, if statement kind is not bound node kind return, then return false. Otherwise, return true. And now all we have to do in the binder is go to our, where we bind our method, which is here. So now we have the lowered body. And now we can say if function type is not void and control flow graph all paths return body, if that is not the case, then we report a diagnostic and say report all paths must return. And we probably return the function declaration identifier span. Actually, we don't want this, we want the lowered body. And we probably have to cheat here a little bit. Probably want to move this guy elsewhere, but hey, for now, good enough. Let's move this close to the other guys here. And then we just say not all paths return a value. What does C# say here? Not all code paths, okay. Not all code paths return a value. Good enough. So what? $76. What's this guy now? What? What are you complaining about? Argument 1 cannot convert from bound statement to bound block statement. Do not hit save? Apparently not. So this one should still compile. Okay, so clearly we have a bug somewhere in our REPL when things are empty or something like that. All right, this works. Now if we do that, that should also work. Interesting. Why would that not work? What? Clearly, I'm looking at it. it clearly does. Am I looking at the wrong version of something? My mistake. This is also something that you want to be careful with when you emit stuff for diagnostic purposes. It's really helpful when you emit this in all cases, not just when now I'm confused. We're clearly emitting this in all cases. Oh, I see. I think our emitting might be wrong. Our emitting says functions last. Or we can probably cheat a little. Do this. Right. And now we should be able to say, all right. Oh, I'm an idiot. I'm an idiot. I'm an idiot. Yes. Of course, when we do this validation, control flow graph. Not all statements, only the last one. Last statement is last. Right? Because clearly, again, the property of a basic block is that you can have multiple statements in it. All right, that works still. This should not work. Yes. And then even adding any sort of dead code here, like var x equals 0, still works because it's unreachable. Now, whether that's a good idea or not is a separate thing. I think in C# that's actually not allowed. I think if we do something like, and we say var result var I equals 10, and we say var while true, and then we say if I equals 0, return result, otherwise e I plus plus, and result plus equals I, or actually more like this. And then we say var z equals yep, it's legal in C# as well. All right. All right, let's fix this one here because that's annoying. Actually, before we do that, let's do the other one first, where we missed the printing. All right, let's fix this one and say git commit fix runner configuration configuration. Perfect. And now this is basically it. This is our return validation. This is our output. Add control flow analysis. Of course, Don't do things like this. But that is pretty much it. Any questions? What just happened? Otherwise, I call it a day because we're 30 minutes over. Took me a bit longer than I expected. So let me quickly go over my notes and make sure I did not screw something up. Nope, looks like I covered everything I wanted to cover. Perfect. All right, so then I call it a day. This was fun. So in the next episode, yeah, what's going to happen? That's actually a good question. I had a few things staged. I'm not entirely sure what I will do next week. There's a few options that I have. So one thing that I thought about doing was starting to emit actual IL rather than just running the interpreter. But in order to do that, we probably have to prepare a little bit of work first. Specifically, right now, what we can't do in our REPL right now is we can't return values. So right now we don't have this concept of global returns. So when I say this, we actually added the error message and says you can only use it inside of a method. That is not how the C# REPL works. And in a sense, you kind of want to have global returns in the context of scripting, because logically, you want to take all the global statements and effectively create a fake function for them so that your entire program is always effectively a set of functions, and the only thing you allow globally are variable declarations. So this way, basically, when you compile files from disk, or whether you're actually compiling scripts, you have the same representation. So in other words, you take your scripting stuff and you lower it effectively into the same representation as a real program, and you run that one instead. So that's something that I'm thinking about, yeah, that might happen or not. So either way, we have a lot of stuff that we could cover. So I'm not concerned. Next week will be fun as well. Yeah, if you have any questions, let me know. Ping me on Twitter. And if you really want to help me out, follow me on Twitch, because I try to get to the next whatever level it is on Twitch that you can reach. That would totally help me. Otherwise, yeah, just give feedback on the video, leave comments, and I hope I see you next week. Bye-bye.